right, so we are on to chapter 2. We are looking at data types and levels of measurement. So there's different types of data, and they require different methods of statistical analysis. So first of all, data comes in two basic types, qualitative and quantitative. So qualitative is non-numerical categories or characteristics, color, name, label, that kind of thing. Quantitative, values representing counts or measurements, temperature, distance, that kind of thing. So quantitative data has two categories. It will be discrete and continuous. Discrete is individual items they're difficult to take a proportion of. They can only take on certain values. Where continuous is easily measured in parts, fractions, decimals, portions, can take on any value. And then there's nominal level of measurement, which is a qualitative data that consists of names, labels, or categories only and cannot be ranked or ordered. So then this is quantitative ones. These are qualitative down here. So eye color, flavors, that's a nominal. Ordinal is qualitative data that can be ordered, such as low to high. So maybe if you rate a movie or you do a restaurant review. Now the interval level of measurement is quantitative data for which intervals are meaningful but ratios are not. Data at this level have an arbitrary zero, which means it's a random zero. So the temperature, when it's 0 degrees, it does not mean that there's no heat. And then for the ratio level of measurement, it's quantitative data for which both intervals and ratios are meaningful and can be multiplied or divided proportionally. Data at this level has a true zero. So like distance has a true zero because 0 does mean no distance. And there are data types and levels of measurement. So I've got a diagram on your handout. Here is a bigger picture of the same diagram. So we have data type with the level of measurement. We've got qualitative that goes to nominal and ordinal, and quantitative that has discrete, and discrete can be in an interval or a ratio, and continuous can be in an interval or ratio. So you've got a little bit more going on with the quantitative. All right, so number 1, we're going to classify each of the following sets of data as qualitative or quantitative, and then we'll move forward from there. All right, so this is section 2.1. Example 1, part A. So we've got brand names of shoes in a consumer survey. So brand names are going to be a category, right? So they're like a nominal type of deal. They're going to be qualitative. So there you have quality. It's about a quality of something, like the color, the size. It's things that are quality related. Whether or not was it good or bad, kind of thing like that. All right, let's look at B. B has the scores on a multiple choice exam. So that's a value that actually has a count, right? So quantitative. So it has a count. So qualitative's like a name, a label, that kind of thing, and non-numerical. Quantitative is about a number, and these represent a count of the number of correct answers, right? So it's going to have a count value to it. All right, part C. We're looking at the letter grades on an essay assignment. So this one was the scores. This is talking about a letter grade. So letter grades are actually going to be qualitative. So we're looking at, like, instead of like a 96 and an 83, we're looking at A's and B's. A's and B's are qualitative. They represent categories, but they are not a number score. You can't make a ratio out of them or an interval. All right, let's look at D. We're looking at the numbers on uniforms that identify players on a basketball team. Well, those are going to be like a label, right? So those are also going to be qualitative. They are qualitative because it's just the name. The numbers, we can't put them in a certain order. I know, like on a football team, certain numbers are for like the quarterback, and some are like for the linebackers and for the ones who do most of the running versus those who are catching the passes. So I know that those have some significance, but not in a numerical type sense. They're still going to be a label. We use that label for that group. All right, for number 2, we are looking for each data set indicate whether the data are discrete or continuous. So this will be example 2. Maybe we can do side by side here so you can still see it. So example 2, we are looking at measurements of the time it takes to walk a mile. So we're looking at time, and so we're looking at now discrete or continuous. That tells us that by our chart, discrete and continuous, these are all going to be quantitative, right? So if it's discrete or continuous, it has to be quantitative. It cannot be qualitative. So these are all quantities. So we have this time. The question is the difference between discrete, that was where it can only take on certain values, but continuous, it can take on any value. So this is time. We're looking at time. And time can take on any value. And because it can take on any value, it is going to be continuous. All right, let's look at B. The numbers of calendar years, such as 2017, 2018, 2019, well, these have to be discrete because you cannot have fractional values, all right? So these are dates, and it's going to be discrete because you can't have fractional values. Remember, we talked about continuous. They could do fractions, decimals, or portions, and calendar years don't do that. So can't not have, or take, it's have. Can't have fractional values. So typically, like, you don't say like 2019 and a half. It's going to be 2019, 2020. So they don't have fractional values. All right. Part C. So the number of dairy cows on different farms. So first of all, let's talk about cows. Do we have half cows or do we have only whole cows? Well, if you have a farm, I'm hoping you only have whole cows, right? If you have half cows laying around, that's going to be kind of icky. So because you're talking about a whole number of cows, this one can only be discrete because, again, you're not going to have fractional cows laying around because that's just gross. All right, hopefully you chuckled a little bit with that and not got offended. But sometimes these examples can help you really, like, oh yeah, I can't have a half a cow. All right, what about the amounts of milk produced by the dairy cows on the farm? So now we have a bunch of milk. Can milk have any value? It can. You can only have a whole cow, but you can have, you know, a half a gallon of milk. You can have a quart of milk. You value for the milk, so that's going to make it continuous. All right. Oops, and I realized my rating. So sorry, my rating was off. I'll give you a second to catch up. So time, it can take on any value, so that made that one continuous. We couldn't have fractional values for the calendar years, so that made that discrete. The whole cows are discrete, and the milk amount was any value, so it's continuous. Sorry about that. I try to watch that, but I was trying to line it up. The last answers were shorter, so I didn't think about it. All right. I'm sure some of you are like, I can't see. What's she writing? All right. So identify the level of measurement. Is it nominal, ordinal, interval, or ratio for each of the sets of data? All right. So part A. The numbers on uniforms that identify players on a soccer team. So we are again talking about something that's a number on a uniform, and I used kind of that example before. It's just a name, right? It just identifies that's player number 8, that's player number 9. That's all it is identification. And because it's identification, that's all it's going to be. Yeah, I just realized, so that's on 2 parts here. But up here we were just naming it as qualitative. Here we're going to go a little bit further, and we're going to name it as nominal. Okay. So part A is going to be nominal. It's more like a name. It's a label, right? So part B. B has the student rankings of cafeteria food as excellent, good, fair, or poor. So this, I mentioned earlier, this is going to be a qualitative type of thing. You can't make like an interval over it. You can't have a fractional kind of thing. This is just another type of label. But it actually can have an order as far as excellent, good, fair, or poor. There's an order in that. And that will make it ordinal because the order does make a difference. On the players, typically the order doesn't make a difference. But ordinal, it will, because there's a difference between excellent and bad, right? So the order will matter. All right. Part C, the calendar years of historic events, such as 1776, 1945, or 2001. So again, these are similar to what we were looking at, but we're looking at a little bit further. So an interval of 1 calendar year always has the same meaning, but ratios of calendar years don't make sense because the choice of the year 0 is arbitrary. So 0 year or year 0, and then you have like BC and AD, right? So the year 0, it's just arbitrary. It doesn't mean the beginning of time because there was time before that with BC. So calendar years are going to be at the interval level of measurement. They can be an interval of time, but they are not going to be much more than that. So they're discrete, and they're going to, they can't have fractional values. They're going to be on the interval. All right, part D, the temperatures on the Celsius scale. And it wouldn't matter if we were talking about the temperatures on the Fahrenheit scale. The answer is still going to be the same. So just like those Fahrenheit temperatures, Celsius are at an interval level of measurement. So 0 degrees Celsius, which is the freezing point of water, it's 32 degrees in Fahrenheit. It's an arbitrary thing. It doesn't mean no heat. So 0 on a Fahrenheit schedule doesn't mean no heat either. So this is going to be interval. So there's no true zero. Okay? It is arbitrary, which means it's just kind of like a random thing. Runners' times in the Boston Marathon. So we had a bunch of runners. They ran the marathon. And so those are numbers, and they matter in order. But there's a difference between the interval and the ratio. So if we're talking about runners' times, can we do a ratio with that? Well, if one person ran the race in 3 hours and someone else ran it in 6 hours, 2 times 3, well, that is 6. So it is double the time. Also, the 0 in this case is a true 0. 0 minutes or seconds or whatever measurement you're looking at means there is no time, right? No time is happening on the race. So it has a true 0, and it's the meaningfulness of the ratios are going to happen, and so this is a ratio level. Okay, there's a true 0 and 0 time, not in 0 degrees. There's a true 0, and ratios are meaningful. Okay. All right, example 4. So, does it make sense? Zip codes are quantitative data because, in general, lower numbers are in the east and higher numbers are in the west. All right, does that make sense? They're quantitative, which means they have a count. Lower numbers are in the east, higher numbers are in the west. I don't think so. Zip codes don't measure distance, right? From the East Coast or from any other reference point. They are qualitative. Now, the numbers in the East Coast might be higher, and let's talk about what could be the cause of that. So you started, whenever they started zip codes, I don't know what year they started zip codes, but maybe they started counting them over here on the east, and then they worked their way to the west. So the numbers might be higher, but it's not because they're quantitative. It's just because that's how they counted them. So like where we live in Texas, we start with 7s. I grew up in Nebraska. It starts with 6. It's just, where they are. So this does not make sense. And they do not consistently measure distance. So they are qualitative. They don't measure anything. I mean, they'll tell you where it's located, but it's not a measurement. All right, so you have a measurement activity. On here, you're going to figure out if it's quantitative or qualitative data. And then you also might be considering if it's discrete or continuous. On the back side, it's quantitative, qualitative, and then you've got to figure out if it's nominal, ordinal, interval, or ratio. And you've got a few of those on the back. So that'll help you. The point of the activities is to help you get a better understanding of the material besides the homework so that it'll be clear to you.